They seem really simple at first, like you get the rules right away.
Hmm.
But then the more you play, the more you realize there's actually a lot of like hidden depth there.
Yeah, definitely. Like you think you're just messing around, but there's often some pretty cool math happening behind the scenes.
And that's what we're diving into today, a game called Entrapment. It looks like a simple shape-fitting game, but trust me, there's a whole lot of geometry going on under the surface.
It's kind of like they snuck a geometry lesson in there without you even realizing it. We're talking rotations, reflections, all that fun stuff you might not expect from a game like this.
Right, you think you're just trying to outsmart the other players, but you're actually, like, secretly becoming a geometry whiz.
Uh,
So for anyone who hasn't played Entrapment, picture a grid, kind of like a checkerboard.
You've got these four different shapes, all made up of squares, almost like Tetris pieces, but simpler, I guess.
And the goal,
Yeah.
super straightforward. Be the last one to successfully fit your shape onto the board.
But of course, there's a twist. Each turn, you roll a die to determine which of the four shapes you have to place. No choosing the easiest one.
And that's where things get interesting. As that board fills up, finding the right spot for your randomly assigned shape, it's like a puzzle within a puzzle.
It's fascinating how this one simple rule forces you to use some pretty fundamental mathematical concepts. Like, we're talking concepts that line up with what's actually in the 8th grade Common Core standards for geometry.
Wait, are you serious? I can tell my kids they're getting a head start on their homework by playing Entrapment.
I'm telling you, playing this game actually checks off boxes in the 8th grade geometry curriculum. For example, there's standard AG1. It's all about understanding rotations, reflections, and translations. Literally what you're doing every single turn in this game.
It's like hiding vegetables in a smoothie.
Yeah,
They're getting their math without even realizing it.
exactly. And then there's 8G2, which focuses on congruence. So basically, shapes are considered congruent if you can rotate, reflect, or translate one to perfectly match the other.
So when you're staring at that board, trying to figure out if that awkward shape will fit,
You're essentially testing for congruence. The game forces you to visualize and manipulate those shapes in your mind.
that's so cool. And I have to ask about those mind-bending rotations they mentioned in the game description. Is there something inherently harder about rotations, compared to flips or slides?
That's a great question, and it turns out there might be. Our brains, they seem to understand reflections and translations pretty easily. Think about like looking in a mirror or just sliding something across a table. But rotations, those seem to require a little more brain power to really grasp.
It's that aha moment when you finally see how to rotate the shape to make it fit so satisfying.
Yeah, those aha moments, those are what make this game so addictive. You're not just memorizing formulas, you're like actively solving problems and building these skills without even realizing it.
Okay, so speaking of skills, gotta be honest. When I first heard about this game, I was thinking to myself, when am I ever gonna need to rotate shapes in real life? But I have a feeling you're about to completely change my mind.
You'd be amazed at how often these skills come up, honestly. Let's just start with something everybody does, packing a suitcase.
Oh, get my attention.
Think about it for a sec. You're trying to fit all these different shapes, clothes, shoes, your toiletries into one fixed space, and you're rotating things, flipping things, trying to make them fit perfectly, just like in entrapment, everyday geometry.
Oh my gosh, I never even thought of it that way, but it's so true. I guess being good at this game means I'm gonna be a pro packer.
There you go. And it's more than just suitcases. Let's say you're rearranging furniture. Same idea. You're constantly picturing how these different pieces would fit together, rotating them in your mind, trying to find that perfect layout.
Maybe that's why I can never get my living room to look like those picture-perfect rooms on Instagram. Guess my spatial skills need a little work. So we've got packing, interior design. What else?
Well, think about careers like architecture or engineering. Those fields, they heavily depend on being able to think about and manipulate shapes to design buildings, bridges, all sorts of structures. Even something like surgery, surgeons need to be able to visualize and work with 3D shapes inside the body.
So maybe surgeons are secretly thanking entrapment for their skills in the operating room.
You never know. But on a more everyday level, let's talk about maps and navigation.
Okay, yeah, I see where you're going with this.
Maps, they're basically geometric representations of the real world, right? And when you're using a map or a GPS or just trying to find your way in a new city, you're doing translations, scaling, even rotations to understand your surroundings.
Hold on, so when I'm turning my phone map around and around, trying to figure out which way to walk, I'm actually doing real-world rotation. That's wild.
Exactly. It's all connected. The more comfortable you are with these concepts in a game setting, the easier it becomes to apply them in real life.
Okay, so we've definitely established that entrapment is secretly building some super valuable skills,
Yeah.
but there's one thing I found really interesting in the description. The idea of filling the entire board with no gaps at all. Do you think that's even possible, or is that like one of those math mysteries that'll keep me up all night trying to figure it out?
Well, it really gets to this fascinating concept in mathematics called tessellation, or sometimes people call it tiling.
Tessellation, like those
Yeah.
really cool mosaic patterns you see in art and stuff. Tessellation, like those really cool mosaic patterns you see in art and stuff.
Exactly. Tessellations, it's all about taking shapes and arranging them to cover a surface perfectly, no gaps, no overlaps. And even though entrapment uses a finite grid, that question of whether you can fill it up completely, it kind of gets at those same principles.
So is there a simple answer to the filling the board question? Like, is there's a secret formula I don't know about, or is it more complicated?
Well, there's no magic formula, unfortunately. Whether or not you can perfectly fill the board, it depends. The shapes themselves, the order they're rolled, even the way the players decide to place them, it all factors in.
So it's a mix of luck and skill. That would definitely make every game different.
Absolutely. And that's part of what makes entrapment so interesting. It's fun and engaging, yeah, but it also makes you think about some pretty cool mathematical ideas even after the game is over.
Like they're planting these little seeds of curiosity, making you want to explore the math behind it all, which is exactly what we try to do here on the deep dive.
It's true. We started with entrapment, this seemingly simple game of fitting shapes together, and look where we ended up. We uncovered the geometry underneath it all, and we even saw how those skills can be used in our everyday lives.
From packing a suitcase to figuring out which way to go on a map, who knew rotations, reflections, and translations could be so useful?
And as you go about your day-to-day, dear listener, we challenge you to pay attention to those subtle ways geometry pops up all around you. You might be surprised at how often you see these concepts in action.
So the next time you're tackling a real-life spatial puzzle, maybe you're trying to cram all your furniture into a moving truck, or maybe you're just trying to parallel park, remember what you learned from entrapment. A little bit of spatial reasoning can go a long way. Until next time, happy exploring.